Hi, it's time for another tutorial on Gerridaj. Today I want to show you how to generate G-code on Gerridaj based on some of the community projects. So this is actually a project which was published a few days ago by one of the users. And in this example I want to show you how you can create such a lampshade by using either an existing project and just by modifying it, or you can also start from scratch and do it. Along the way, I will show you also some of the functions of the nodes, so you know what you can modify and how. So this is the final lampshade which was published in the community project, and you see it's not a normal STL mesh which you can slice, because you have this pattern here. Normally you can only print it with directly generated G-code, or how it's often called custom G-code, because you need these variations in the toolpath, which normal slicers do not produce. So, but this is achieved in one of the later stages of the design. As you can see, we are here in the end of the node graph, and what you see here, this is the viewer node connected to curve modifier. So if I deactivate this viewer node, and you see what the curve modifier does, these are your toolpaths. So the toolpath of your 3D printer will move that way and produce that kind of shape in the end. Of course, the sharp corners will be probably a little bit smoother, because it's molten plastic. It's not that, how to say, you cannot just define any form and go with the sharp curves with a 3D printer and expect that these curves will remain sharp. So the corners will be probably a little bit smoother, as you can see here in the preview. But in general, it can come pretty close to that, what you see here. So how do you achieve that? If you grab an example, you can see the entire node graph here. And I would say the best way is just going backwards. So you start at the end and you see what is happening where, and at each node. So you can deactivate or disconnect the viewer node and see what's the last node doing. So the last node is producing this type of curve. Okay, then you just see what is the node before doing. And the node before is the spiralized node, which is creating just a continuous spiral. This is what you need to put into your curve modifier. So this is a continuous spiral to avoid a seam. So in contrast, you could achieve that also with a bunch of rings or circles placed at different heights. It would look similar, but you would have a seam there. So I can show you a seam also here. If you this is already set to have a seam, so we need to find it where it is. I will modify the layer height for now for demonstration, so we can find it here. This is the jump that you have in this spiral with this setting. And same kind of jump you would have if you use just circles, because this is basically a circle at constant height, so this is in a XY plane at a certain height. If you change this setting to continuous spiral, then you see it's spiraling upwards, continuously changing the height. So there's no jump. It's actually much better for, or it's not always, but for many designs, it's better to have this continuous setting set on, but you can just try whatever is better for you. And now we're going back to 0.2 millimeters here. So take care, the units are mostly in centimeters, but there are a few nodes which are using millimeters as units. Like for example, layer height in machine node, I think is in millimeters, so take care of that. And you see here now we have no step, I deactivated that, so we have now our spiral. So, and you can modify that spiral. And you can modify that spiral now with any kind of function that you have here. So you can take a sign, for example, and then it will look different. You see, this sign is very coarse because you have not enough points in your spiralized node. So you need to take care of all of your geometry of each node. So if your spiral only producing 100 points per turn, then your modulation will be also not very fine. So you can just refine your spiral and produce much more points. That is not helping here because if you see the loft before, it's also very coarse. So you need to refine your loft. So, and if you refine your loft, you can change here the number of segments for lofting. So it is basically the same as subdivisions, if you know it from other programs. So if you set it to 500, let's say, you see it's now much smoother surface. And now the spiral would be much smoother. And here, let's see, what do we have here? Maybe we can resample it to even more points. So yes. So if after your refinements in previous nodes, if it's still not enough, you can either increase your points further because it's very, very small layer height, 0.2 millimeters. So you can use more samples here, or you can just force a resample here. And then you will get a finer curve, so as fine as you want. But keep in mind, each point will also result in a point in your G-code later on. It will produce a very large G-code, and if you have way too many points, so if the number is extremely large, some printers may struggle with memory for that. So keep in mind, only use that resolution that you actually need. So because normally the lines will be smoothed by the filament anyways. So now you have all these functions, so you can play with that. You can change the amplitude here, you can change the frequency. Let's see, let's make it frequency less. And then you see you have these longer curves and so on. You need to play with all the settings because there are a lot. I probably should explain each node separately because each node or most of the nodes have many settings which you can play with. But most of them, if you just visualize your geometry and play with the settings, you will see and understand what they are doing. So, and for example, here the direction displacement of your curve, you can modulate it in z-axis, for example, which does not make sense in this case. This is going high, up and down, you see. You will not be able to print it, but you can produce such commands if you want to. So there are cases where you can do it, but in this case, it's not beneficial. So therefore, we're just going in radial, and you see this can be perfectly printed because the all the displacements is done in the XY plane. So play with the functions, play with the amplitudes, with the frequency, with some pattern effects. So you can set here the alternation block size, let's say to 10. Then it will, you see here on the curve, it has 2 repeating curves, and then it flips the direction, and this has also 2 repeating curves. So you can change that, let's say to 10. Then you have 10 repeating curves, change of direction, 10 repeating curves, and so on. So you can play with all of that. You can add the skip pattern, for example. You can, well, that's too much. You can skip, let's say, 10 every 10. No, every 1000, that's too much. We just skip between the alternation blocks. So, and what this will do, you see you have your curve, then you have no modulation at all, and then you have the flipped curve. So these are useful settings for some situations where you cannot avoid the seam. Otherwise, if you define a skip pattern, it helps a lot to hide the seam in your lamp shape, for example. So if you're using this skip setting, in most cases you will not recognize any seam at all. So this is actually quite useful. Okay, you can play with that. You can also, if you want to have it, let's say parametric, you can just add a number node here and connect it, let's say, to amplitude. And if we connect 0, you see it has no amplitude now. So let's disconnect it and see what value do we have here? So we have 0.08 centimeters, and this is producing that kind of variation. So you know from that you actually need very low numbers. This information is useful to parameterize your number node. So you can say your minimum value should be 0, that's okay, but your maximum value is for sure not 100, it will be too much. So you can say you need probably 0.2 as a maximum and very small steps, because you are working with very small numbers. You can provide a custom name for your number node, but it will actually inherit the name of the connected port. In this case, if you want to change the amplitude, it will just inherit the name amplitude, and that's okay in your case. So it's connected to the amplitude node, and you see 0 produces nothing, but you can set another value now, and here you see it changes. So in that way you can add the variations here. You also can notice these timestamps. So your curve modulation now is using very large number of points per turn, and of course this is a little slow then in that case. And also the spiralized node is a little slow in our case, so you should take care of your performance. So for example, if you are already here, then you have no chance. You need to change these settings and then to wait this 200 milliseconds until it's done. But let's say if you want to change your overall appearance of the base shape of the loft, then you don't need to keep these nodes connected, because they then consume time. Let's say, for example, you want to change the radius here of your circle to make your lab shade just bigger. If you do it just like that and increase here the radius, okay, radius is connected to number series, so you need to modify that. And you can, for example, change the start value here, and then it will increase the radius. Let's do it. And you see it's take quite some time, right? I didn't notice if this, okay, we use here a custom formula, so that's probably not helping. So you need to modify the formula here to change your radius. It's not my formula, or maybe modify it, but I guess if I change this offset here, this should change also the radius. Let's try it. So you see it's increasing the radius, but it takes all this time you need here as well for the production of the spiral and also for the production of the modulations. And if you just want to change your base shape first to get an idea how your final mesh-like structure should look like at the end, then it's much better to disconnect the later nodes first, because currently you don't need them. And now you can change and play with these numbers, and this will be much faster because it only executes the required nodes and not the other ones. So, and if you see, this is just instant here. And if you define the formula in a different way, so let's say if you use the variable names here as a step or a start value here, then you can also connect, let's say we put a 5 here, and we define a start variable here. And start is the same value as you see here in the start value. If you hit apply, it looks the same, but now you can connect a number here. And let's set it also to 5 and connect it to the start value. And now you can change it. And now your design is parametric. So this is a very nice way of creating series of designs. So basically you're creating here a small system which allows you to do a lot of variations very quickly in your design. And yeah, you see, because how versatile it actually is. So this original example was actually a square lamp and not a circular one. And you can see that by this disconnected rectangle. So because this is coming from a different example. So if I disconnect the circle here and connect the rectangle, you see this was the original example. It was a rectangular lamp with rounded corners. But another user wanted to have it round and wanted to have some circles. So you can reuse everything before and just take another base shape like here, a circle, and then connect it to the loft, and now you're done. Everything else is still working the same way. So your spiral, your modulations, everything will look the same, and one simple change changes everything. And it goes even further. You can change from a circle, you can change the number of segments here. And this means this is not actually a circle, that's a polygon. And if you do a really low poly here, you see, you will get also another shape. And the lowest one is 3, because otherwise it's just a straight line. It will not produce any closed surface here. Okay, this is not closed, but if you close the caps in the loft, then it's a closed surface. If you want if you want to have a mesh, and let's say STL or FreeMath, you can just connect this export mesh node, and then you can go there, define what you want to download, which file format, and then you can just export it. Then you can slice it in a different program, and then you can use it. This node is actually free, so STLs are free. You can generate them and use them however you want. Okay, so we have seen we need a spiral node to create this spiral. And for that we need some kind of base shape, and this base shape is coming from the loft. So what does the loft need? If you disconnect everything from the inputs of the loft, here you need to take care. So some of the older examples use the older definition of the loft node, which has different inputs. So if you see some different inputs or inconsistencies, like curves connected to subdivisions, you need to remove that loft and just take a new one, because some things have changed recently. So modern or the recent loft node has only 3 inputs. This is contours, subdivisions, and mesh smoothing. So this should look like that. So in these 3 inputs, in contours you just put your curves, so which will be lofted, and you can see it here in this circle. What this circle is producing, this is producing, I guess these are 10 different curves in 10 different heights. So you see, or this is our 11. You see the count is 11. And the vector takes also a number series as input, is also a count 11, and this is producing 11 Z values, as you can see here. And it can then shift your rectangles, or it can shift your circles in that way. So in this, all these contours, you connect to the loft, and the loft creates a connection between them. So this took a little bit longer because I forgot to disconnect here. And you see it's very significant performance change if you do it the right way. Okay, but what does it mean? You can connect like one curve, or one node, because this node is using this input matching system to create multiple curves from one node. But you could also just use multiple nodes. Let's say we have one circle. Let's copy it. If you see, the default circle has a radius of 10 and it's in the XY plane at 0 height. So if you shift the second one, let's say to height 5, now you can connect one circle to the loft. It will not produce anything, because one curve is not enough for lofting, right? But now you can connect also the second one. So this is this spawner inputs. If you have something in multiples, like plural contours instead of contour, or curves instead of curve, it means it is a spawner input. You can connect as many connections to it, and this is creating a new real input, which things are connected. So you have now 2 curves connected to the loft, and this is lofting between them. So it's, how to say it, it's not very meaningful usage of the loft node, because you can achieve that with extrusion, or you can just grab a cylinder if you need a cylinder. So you would typically not do that with circles of same radius. It does not make much sense, but it's just to demonstrate. You can connect separate curves in separate nodes, or you can also connect these combined curves coming from one node. It's just need to be a collection of curves, so it will loft between them. And that's not all. So you have, as always, you have a lot of settings here in this loft node. So for example, you can use some smoothing. You can add here some smooth iterations. If you connect back the original, it will try to smooth your shape. You see its difference. So it was probably too much. It smoothed all the edges away. So you can try different iterations here. This is now, it uses too few curves actually also. So you can try to increase the interpolation between the curves. And this will change your smoothing results, because then it will affect much more only the edges if you smooth and less the entire shape, as you see here. So you have a lot of control in this loft node. Just play with the settings here. Sometimes you need curve sorting. This is also important because you can do very different things with the loft. So let me show you. Disconnect the end, we remove the circles. If we take a curve node to produce a much different curve. Let's say we want a curve not in the XY plane, because we want to do now very different type of loft. We do a curve in the XZ plane and we create a strange shape for that. And we create a closed curve. So let's do something like this. It will probably not win a designer contest, but for demonstration purposes, I hope this is okay. So this is our curve. Now we have one of them, you see that? And you cannot do anything with one curve, and therefore we will just distribute it in a circle pattern. And let's say we want 15 of them. So you see now we have this curve distributed, and you see the orientation is not what we want. So we want the orientation to be radial. So I think here we can change the orientation. Oh, this is actually, this is vice versa. This is tangential, which should be radial, and tangential is radial. So this is a bug. Okay. So now we have more height than radius. So let's move them a little bit apart. Let's say spacing is 20. So now they are far more apart. So now you can loft it. So, and if you loft it, you see it lofts from one curve to the next. So, and you see this is open here, and it should be closing if you use this end to start option. So now it's closed, but somehow it's it has skipped one curve. I need to check why is that. Let's see again. So we have all the curves. Let's remove the subdivisions for now. Okay. If we remove the subdivisions, it seems to work correct. So this was the issue of subdivisions, because this is a closed curve, and subdivisions is not recognizing the closed curve. I think this is a bug. This needs to be fixed, but it's not that important, because it's actually important, but you can change it in many other ways. You can just increase the number here instead of using subdivision. You just increase the count here, and you achieve basically the same. So there are always many ways of achieving things here with this kind of visual programming. So you need to think a little about the connections, about the geometry, and then you will find a way to do many things in many different ways. So, and we will increase the smoothness much larger here, and you see it's, I think it's for 3D printing, it's actually smooth enough. And yeah, this is a different kind of loft. So I am not even sure if it's also called loft and in other programs, but for me it's still a loft. And you see, if you look into that, it's very fine mesh, and it's a closed mesh. So you can download it as STL, and then you can print it as solid volume with infill. So it's not just outer wall. This was the loft. So, okay, but we are now a little bit away from our example. So you actually wanted to see how you create this lamp, right? And we started from the end. We had our modulated curve, we had our spiral, then we have seen we need a loft. And the loft needs some type of curves. So this means you need to find a way to create a number of curves, ideally at different sizes, maybe different shapes, and provide them to the loft. And here as well, you can do it in very different ways. You can use a circle, you can use a rectangle, you can connect a number series to the circle to create many circles, as you see here. If you disconnect number series from here and just one circle. If you connect a couple of vectors to the center of one circle, it will create many circles defined by the vector position. If you connect now the same number of radius to the circle, it will vary the radius of each circle, which is produced by this number series, because you see number series is producing 11 numbers, and which number exactly is created is defined by this formula, which you can modify yourself, or you can just use a preset like linear. If you do linear, it will produce just something like a cone here in this example, you will see, because the number is just increasing constantly at a constant rate. It's not very interesting, but you can do it if you want. More interesting it will get if you use a custom formula, or you can put a graph mapper here in between and modify the shapes as well. I will show you that to you now. Let's go to other layout so I can show you what is in the number series. So you see, if you look in the number series, it's producing these numbers. So sometimes you need this information, and you can just open this node data window and then look inside which data, which numbers are produced. So, okay, now let's go back. If you need a variation of your curves, as already said, you can use number series with custom formula, or you can just use a graph mapper here, insert on the edge, and then you can use that. And you see, this is now combined. This is now combining the custom formula and graph mapper. And then it makes it a little bit unpredictable, because you already have modified numbers here, and then you modify here again. So in this use case, you can just use normal linear here, for example, and modify it. Or you have like a normal function, where you can have x going from 0 to 10, and y is going defined by the function. So now you can modify it. So and here with the graph mapper, you can what it does, it allows you to create these variations in your curves much more quickly as you can do it with the custom formula. Because if you look into that Okay, I already deleted it, but you saw earlier it was a quite complicated formula. You need to understand it first, and then it's also not easy to modify. Yeah, if you want to do such variations, it's much easier to use just a graph mapper. Graph mapper is one of the premium nodes, so it will deduct your credits, or you need a premium subscription for that. But yeah, you can use if you can. If you need more precision, this feature was added just recently. You can expand the graph mapper, and here you have some more options like snap to grid, display the coordinates of the points, and so on. You have here quick info, what you can do, because you can add points, you can remove points, you can disconnect the tangent, you can do lots of things here. So let's demonstrate that if you add a new point, you have more control here. You can disconnect this handle, and then you can create sharp angles. You can delete points. You can do many things here. You can define the different function, let's say polygon. Then you can create some kind of these steps, which we also had before. And here we can just vary the things visually, which is kind of more intuitive than doing it with a formula. And then you can connect it to your loft and see how the surface will look like. And you can play with it. It's a very powerful node, so try it out. If you need to remap the values, you can also double click, go inside, and then you can create a custom output range. So I would, in most cases, keep it at default values because it's the easiest to understand what is going on. So all the values are just normed to the range between 0 and 1. But if you know what you do, you can change this mapping. So you can change the range. Here you can also switch the function. This is the same what you are doing here. So you see everything changes if you play with that. So if you need something round, the easiest one is just to use this arc. And if you need it more smooth, then you need more curves. So you need to just define more of them. And for that you need to increase the counts in your number series. So, and here we are already at the beginning. So you see, all you need is actually some kind of a curve, then a way to create a set of them, connect them to the loft, spiralize, modulate, and then you can export it here in the machine node as gcode. Let me show you. If we connect to our spiral again, it's way too large now, so we need to reduce the radius so it fits in our print bed. So now it fits. And here we have our modulation. And we can preview it now. So this is a new function in machine node. You can preview it now, how it will print. So, and if you are in machine node in this G-code tab, you can click this play button. And after that you will see this simulation window. And you can do also a lot of things here. So if you're doing some non-planar stuff in Gerridaj, then you need collision detection, because you see you have a model of print head which you can change here for your printer, because it can be larger, longer, so it can have different size. And if you do non-planar printing, it can collide with your print. And to avoid that, you have here the settings, you can adjust it, and then you can run collision detection. And of course here it will not collide, but if you do Okay, this is quite a large number of points. It runs the collision detection here. It will take now a while, but you don't need to do it for these shapes, so you know for sure here it will not collide. Okay, and if you want to see how it will print, you can just hit this play button. And take a look. So it's quite slow now because we are running the collision detection in parallel. And we have a lot of points here. But you see, this is what your printer will also do. And so on. Now you can export it from here. It's not very important for normal 3D printing because there normally nothing will collide. If we go out here, let's take a look how many points we have. Yeah, this is actually a problem. So we defined here over 1 million points. So this is a huge number. So this is difficult, of course, for the GPU even to run the collision detection because it's looking at each point and looking for collisions. So if you don't need that high of a resolution, because some printers will struggle with that as well. So if you download that file, the file size will also be quite large. Let's try that. Let me see how big the file size is. So it's like 46 megabytes of G-code. That's huge. So normally you never need that many points. So, and yeah, for that, just reduce your resolution if you don't need it. Let's say we do 1000 here. The curve is still smooth enough. You see, it's very smooth. And if we look now at our G-code, and it's, yeah, of course, it's much smaller now. Okay, that's basically it. So you can start with an existing example, just look into it, add new nodes into it, remix it somehow, try to understand what the previous contributor did, how he or she thought, and just go backwards and create your own variation, etc. You can play a lot with these things, so you can insert new nodes in between. I think this allows quite a lot of room for experimentation, actually. So that's it for this example. I hope in a few days I can do another one, or maybe explain a node more deeply with all the settings. If you have some suggestions or some kind of video you would prefer to see first, you can write it in comments. So which information is actually more important to you, because for me everything is clear. So because I created it, I know every node, so this is like self-explanatory for me. But I can understand that if you see this first time, nothing is actually clear, so you don't know what to do. But I don't know what to explain, so because I don't know what you don't know. So let me know what should I explain next, and I will do it hopefully in next few days. So try it out, and yeah, have fun. Thank you for watching. Bye.